Hi there, my name is Ken Stafford and I am doing the solutions to this Naiker Maths worksheet, which is angles in parallel lines. And I'm just going to take you through how I would solve them. There are no solutions on the Naiker Maths website, which is why I'm going to go through them. Question 1 here. Work out the size of the angle marked X. So that is this angle here. And we are told this angle here is 47. So the answer isn't 47. We can see that the red angle is acute and the blue angle is obtuse. But because these lines are parallel, this angle in here is the same. It is also 47 degrees. So now that we know that, we also can figure out X, because X will be 180 take away 47, because we've got a straight line there, and those two angles on the straight line will add up to 180. So X is 133 degrees. Other ways we could have got that, we could also have known that this angle here was 47. Therefore, these angles are co-interior and they sum to 180. Lots of ways of knowing it. Giving the reasons, well, what we can say is angle EBC equals 90 degrees. Doesn't equal 90 degrees. Angle EBC equals 47 degrees because it's a corresponding to angle EFG. And then we're going to use the rule angles on a straight line add up to 180. So ABE equals 133. Angles on a straight line sum to 180. Okay. So what I generally find is people are quite good at figuring out what the angles are, but struggle with the rules. So that might be something you just need to make sure you know the rules for angles in parallel lines. Okay, question 2. So when I do these, straight away I just sort of look at them and think, right, this angle here and this angle are the same. Oh. Those two are alternate to each other. So angle Y is 64 degrees. And because it's alternate, angles are equal. And question 3. We're told that we've got 3 straight lines. That's told to us here. And we're told AB is parallel to CD. So this one here, parallel to this one here. So that means we're going to get some angles that are the same. So this angle here, this 113, will also be 113 here, because they're vertically opposite. It will also be 113 here, because it's alternate to this angle, or it's corresponding to this angle. So we've got 4 angles that are all 113, and the other 4 angles are the same as well. And X is one of the other angles. So how do we get that? Well, if we know this angle is 113, it means X must be 180 take away 113, so 57, because those angles on a straight line add up to 180. So if we work out the value of X, it is 57 degrees. Reasons for our answer. We use corresponding angles are equal. And angles on a straight line sum to 180. So a lot going on in question 4. Find the value of x. So angle x is here. And straight away, how are we going to find that? Well, x must be 150 degrees. That's a corresponding angle over here. So straight away we can say x is 150 degrees. Corresponding angles are equal. Because of the parallel lines, those two angles there are corresponding. They are the same. Find the value of y. So what I always try and look at on these is, well, if this is 85 here, so is this one. And actually, so is this one. Again, corresponding angles. So this angle y here is the same as here. It's also the same as here and here. So now we can use angles on a straight line, add up to 180. Angle y must be 95 because we've got a straight line there. So angle y is 95 degrees. Well, we did use corresponding angles are equal. And we also used angles on a straight line, sum to 180. So I'm just trying to do the answers at the same time, so I don't have to come back through and do them at a different time. So if you're waiting for me to write things, it's just so that I can also upload the handwritten solutions as well. ABCD is a parallelogram here, question 5. So all these opposite sides are parallel. So again, we're going to have some angles that are the same. Straight away, this one and this one are alternate. So we do know this one. We therefore know a few other angles. We can figure out this one because we've got a triangle here. Let me just highlight it. Didn't want to do it in that color. There's a triangle here. So the three angles inside there will add up to 180. If we add up the two we know, they add up to 79. So 180 take away 79 tells us that this angle here is 101. How are we going to get angle x? Well, this angle is 120, as is this angle here. Opposite angles in a parallelogram are equal. That means that x must be 120 degrees, take away 101, so it's 19 degrees. Again, it's going to be the reasons that often catch people out here. Well, what did we use? We used alternate angles are equal. We used angles in a triangle sum to 180. And we also used opposite angles in a parallelogram are equal. And what you need to make sure you're doing on these questions, which are about parallel lines, is you need to make sure you're using the rules for parallel lines. You can't just get away with saying angles in a triangle add up to 180. You've got to use those rules too. Okay, so we're told DE equals AE. So that's telling us that we have an isosceles triangle here. This side is equal to this side. So it means these two angles will be the same as each other. Because we've got some parallel lines, this blue one here is alternate to this one. So straight away we can say this one's 38. And then we can work out the yellow angles. So if we do 180 for the triangle, take away 38, the remaining two angles, the two yellow angles, sum to 142. So one of them will be 71. So these are 71. And then last of all, we've got a straight line. So x can be found by doing 180, take away 71, which is 109 degrees. Again, the reasons, well, we used alternate angles are equal. We used base angles and isosceles are equal. We also used angles in a triangle, sum to 180. And we also used angles on a straight line, sum to 180. Let me just expand that a bit. Again, I'm just creating the solutions at the same time so I don't have to come back through. So sorry you're waiting for me to write that. And then final question on this sheet. Again, we got some parallel lines. All these questions involve parallel lines. So we're told these are parallel. Which means we're going to get some angles that are the same. For instance, this one, this 53, is alternate to this one. So we can straight away say that's 53. We do know this one is 127 because we got angles in a straight line there. Other angles that are the same, this one and this one are alternate. So we know 28 degrees. And how can we get angle X? Well, if we look at it, there is a triangle here, which I might draw separately. And we know two of the angles already. We know this one's 127. We know this one's 28. So we can figure out angle X just from the rule that angles in a triangle sum to 180. So these two that we know are 155. So if we subtract 155 from 180, we will get 25 degrees for X. And it didn't ask us for any other reasons. So we don't need to include them, but the reasons we used were angles in a triangle sum to 180. Alternate angles are equal, we used twice there as well. Okay, hope that was useful. There are more solutions for Naiker Maths on my website, which details of which are in the comments, as well as links to the file and the solutions.